Okay, now Pilo, what I'm going to do is I'm just going to put the diagram up, and I want you with the other learners at home just to check it out and see if you understand what's going on here, and then we'll start with the question, okay?
Okay.
Okay, we've got basically, I want you to imagine that AD is something like a flagpole or something standing up, all right?
Okay.
So this angle there is 90 degrees. Then over here we have an angle theta, okay?
Okay.
Then furthermore, okay, now this angle theta is the angle of elevation of A from B, okay? So that means if you're looking up towards A, you are looking up by an angle theta. So pretend that you, Pilo, are standing over there.
Okay.
And that's the hypole. You're looking up, all right? Okay, so the question says AD is perpendicular to the horizontal plane BDC. So now this, I want you to imagine there's my pole going up, and then here's the horizontal plane, which is given by this triangle BDC. Okay? Can you imagine that? And they tell us that this angle over here is beta. This length DC is x, and that angle over there at C is alpha. Okay. So I'm going to quickly highlight the information that they give us, and then I'm going to tell you what they're asking us to do. Right, so they tell us that the angle of elevation of A from B is theta. Okay? They tell us that this angle over here is beta. This angle down here is alpha. That length DC is x. And what they want us to do is they want us to find the height of this flagpole. So we're making that a flagpole.
They want us to do it.
Okay, they want us to find the height of that flagpole. Are you with me, Peter?
Okay, okay.
Okay, now, with most of these three-dimensional trig questions, Pilo, there's always two triangles, okay? Now, what's going to happen is they're going to ask you to calculate something in one triangle. And can you see that what they're asking me to do is they're asking me to calculate AD, which is in my top triangle. Can you see that?
Yeah.
Okay. But then what they do is they're quite sneaky. Most of the information that they give you will be in the other triangle. Okay? So can you see in this bottom triangle, BDC, we've got lots of information. We know that DC is x. We know that that angle is alpha. We know that this angle is beta. In this top triangle, we know almost nothing, but that's what they're asking us to calculate, is that side AD. Okay. Now, what you're going to do, Pilo, is you're always going to look at the question and you're going to say, where they're asking me to calculate something, that is where I'm going to end up. But I'm going to start with the triangle where I get all the information. And what you always do is you calculate the length of the common side. Can you see that BD is a common side? It's common to this triangle and that triangle. Okay?
Okay.
Okay. Now, what the question says is, the question says, I must find the height of the flagpole AD, and I must do that in terms of x, alpha, beta, and theta. So I'm not going to have an answer like 5 meters. My answer is going to be in terms of beta, theta, and alpha, okay, and x. Okay. Now, Pilo, if we look at this bottom triangle, this is not a right-angled triangle. So if we have a non-right-angled triangle, and what I'm now trying to do is I'm trying to calculate the length of the side BD. We use the sine and the cos rule. Do you know the sine and the cos rule? You've heard of those before?
No, I haven't.
Okay. Now, the sine rule is sine of an angle divided by the side across from it is equal to the sine of the next angle divided by the side across from that, and so on. Pilo, your line is very, very bad. Okay, we seem to have a little bit of problems with Pilo, but I'm just going to finish the question, and then Pilo can watch at home, and so can the rest of you. Now, if we look at this bottom triangle, in this triangle, I am going to be using the sine rule. And we need to remember that the sine rule always works in pairs. You've got to have one complete pair. That means the side, the angle and the side across from it. And then if you have another angle, you can calculate the side across from that one. So what I'm saying is, if I have a look here, I do have that angle. I know that that is beta, and I know that the side across from it is x. So over there, I have one complete pair. Then I know that this angle C over here is alpha, and I am looking for the side across from angle C. So that's pretty easy. I'm going to substitute into the sine rule. I'm going to say sine of alpha divided by BD, and BD is now the common side that I want to calculate, is equal to sine of beta divided by x. Now what I'm going to do is I want to make BD the subject of my equation so that I have an expression in terms of beta, theta, alpha, and x for BD. So there's BD. If I cross multiply and I make BD the subject of the equation, I get that BD is equal to x sine alpha divided by sine beta. Right, so that is very important. You're going to usually get two triangles. One triangle is going to have all your information in, and the other triangle, they're going to ask you to calculate something. So what you're going to do is you're always going to start out with calculating the common side, and the side BD is common to both of these triangles. Right, now I have the length of BD in terms of x, alpha, and beta, and now I want to find an expression for the height of the flagpole AD. Right, now, because my top triangle is a 90-degree triangle, I may use my trig ratios. Now, if you are standing over here at theta, the side that we are looking for, AD, the side across from us, that is, the side that we're looking for is AD, and that is the opposite side. The side that we have is this side BD, and BD is adjacent. Now, the trig ratio that uses opposite and adjacent is, of course, tan. So I'm just going to make some space for us on our sketch so that we can quickly write this down. Right, so we're going to say tan of theta is the opposite side, which is AD, divided by the adjacent side, which is BD. Now, the question stated that we must find the height of the flagpole AD. So I'm going to make AD the subject of the equation, and I get AD equals BD multiplied by tan theta. But now I do know what BD is because I've calculated that earlier. So I'm just going to put the two together, and then I'm ready to go. So in this place of BD, I will now say x sine alpha divided by sine beta, and then of course I still have to write the tan alpha over there. Sorry, the tan theta. So there I've done it by first starting out with my information triangle, calculating the length of the common side, and then moving on to the triangle where they're actually asking me to calculate something. I've managed to calculate the height of AD, and that is in terms of x alpha, theta, and beta. This question is straight from the classroom mathematics textbook, and I think it's really important that we first understand the concept of the information triangle and the triangle where we actually have to work in at the end. And when in doubt, I think you must always calculate the common side BD in this case.
Keep that frequency clear. Keep that frequency clear.